Hello everyone. I'm just working on the electric scooter and just showing here some paperwork that part of my research that I'm studying and learning about uh, how to make an alternator charging system for an electric vehicle. This is part of the research that I have found. If you look this up on Google, you can research this on your own. Alternator charging system for electric motorcycles. And it just shows basically how, let me turn these off. It basically shows how using alternators can extend the range of an electric vehicle. So with the alternators, they're able to go a further distance on 3 different tests. They were able to go a further distance with the alternators, as you can see here. And this is without. So you can research this on your own. And I'm just sharing what I'm studying, part of what I'm studying here. Alternator charging system for electric motorcycles. And it's a way of extending the range of... Oh, hi Charmer. Charmer. She likes to see what I'm doing. Hi. 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 So what I changed on the scooter since the last time, the last test, was I had trouble with the with the rod that was connecting the alternators together. I was running 4 alternators before, and now I'm trying 3. So I had an alternator out here and one on the other side, so basically on the other side of the frame here, out here. And the rod that connects the alternators between this alternator and the next one, it broke. So what I did is I just cut it shorter, and I took the outside alternators off and I put one of them in the middle. So this will be my first test with running it that way. The other problem I had was the sprocket that I was using, which I think was like a 26 tooth, and this is like an 11 tooth, I think. It has a D shape inside, and this is a double D. It has 2 Ds, like 2D. I think they call it a double D. And I couldn't find one that would fit on this motor shaft that was a large size. So I'm going to look at, I was using JB Weld, and it just stripped the JB Weld out. So this is the correct sprocket, but it's very small, so it's not going to turn the alternators fast. Hi, Charmer. So I do want the alternator spinning faster, but I'll work on that later. So for now, my cat's looking at the scooter. She's very interested in electric vehicles and technology. Okay, so we're going to go ahead and do a test. So the way we're running this today is we're basically, again, this is similar to the last time I had the alternators running here. The alternators are wired in series. They're producing AC, and my full wave bridge rectifiers are converting the AC to DC, and I'm running those 3 in series. So one here and then those 2. And that power, right now I have it set to keep these 2 batteries and these 2 batteries charged. And so these are in series, these are in series, and then together they're in parallel, 24 volts. These are 12 volt, 10 amp hour batteries. These 4 batteries are wired in series. They're powering this 6 to 6 to 60 volt, or 9 to 60 volt, 9 volt to 60 volt controller, which is powering our, spinning the motor, turning the alternators. And these batteries, these two and these two, are powering the 24 volt controller, which is running the 500 watt drive motor here. So, by the way, if you have any of your own research that has helped you understand how to use alternators or generators to keep batteries charged, or to extend the range, please do share in the comments once the video is posted, because I'm very interested in learning about how to do this. And I learn a lot by experimenting, and that's what I'm doing. So I'm experimenting, and then I study, and then I experiment, and I study. And I try to study people that are doing something similar to what I'm doing. So far, I'm finding it helpful to study Rick Friedrich's, and he has a YouTube channel. And we're very grateful to Rick for everything he shares on his channel. And I don't understand everything that he's doing, but I'll continue to study his work. I have his diagrams with me, some of the simple ones. This is some of the research that I'm studying. This is Rick Friedrich's research, and that he shares with everyone on his channel. So I'm also experimenting with these circuits as well. And if you understand in very simple words how to make these systems work, I'd be very interested in learning from you. So please share in the comments once the video's been after the stream. So I have a wide-angle lens here, and we ordered a lens that screws onto the camera. I'm sorry, to the phone, but that will be here probably Monday. So for now, I'm just going to use the clip-on. So this may not stay in place very well, but I'll do my best. All right, let's go ahead and do some test run here. So let's go ahead and see what our voltage does here. So we have 26.40 volts, and I'm going to go ahead and get the alternator spinning here. Oops, I got to turn the power on. My light switch here. That's power. Okay, let's see what we need to do here to get our voltage to go up. There we go. Okay, so we got, and our voltage is going up, so we'll keep charging our batteries up there. It does seem more stable being in the rod not being so long. When it was real long, it was moving a lot, and it ultimately broke. The rod did. Let's see how this does. Hi, Charmer. mounting the lens right now. Or mounting the phone. And then I'll get the lens on it. Okay, lens. Oh, it's dirty. Excuse me for one moment. I need to work on the wires real quick. I forgot something. I'll be right back. Charmer. Hi. Hi, Charmer. How are you? Okay, my cat's here to say hi again. She likes to be in the videos. She's purring right now. Hi, Charmer. Aw, so happy. Okay, I just need to hook the I gotta power up the 24 volt controller. Get this plugged in. Okay. And let's see, that's gonna go to 24 volts. We have 24 volts right here, so let me disconnect this right here. And this one right here. And then I'll connect So this is just more testing, and I'm just streaming more of the experience of my learning, which is what this is, and learning how to do this. Oops. I'm learning how to build an electric scooter with extended range. Okay, that's ready. Now we're powered up. Okay, we're ready to go. Hi, Charlie. Charmer me on video once more. She's looking at the batteries. What do you see, Charmer? What do you see? Oh. Oh. Yeah. Hi. Hi. Okay, so we're gonna go for a ride. Oh, I have a cat here. Hi, Charmer. She's saying hi. Okay. Let's go ahead and ride the scooter. And again, if you have any ideas on how... I mean, I know a lot of people have already built electric vehicles and electric scooters with alternators and generators and self-charging systems and range extenders, but if you want to share your favorite range extender or alternator charging system for an electric vehicle or electric scooter, please do share that in the comments, because I really enjoy learning from those of you that also enjoy learning about possibilities and what can be done and what we can create by just using technologies that have already been tested and have already been experimented with and are also being perfected and just improved through of testing and experimenting and building. Okay, so let's get this going. All right, here we go. Oh, the scooter broke down. Okay, so here's what I'm noticing. Looks like the scooter just broke down. I don't know if I can fix it at the moment. It's the motor, the drive motor that makes the scooter move. The sprocket is just free spinning on the shaft. So I don't know if I can make something. I don't know if I could make something that would. This is very interesting, everyone, because the last test I did, it was. Let me go ahead and take the camera off take the wide-angle lens off, and let me flip the camera around. Hi, everyone. Testing is going very well. And I'm very excited right now. I actually like, this might sound crazy, but I like when things go wrong because I learn. It's really interesting because last time what happened was I don't prefer that things go wrong, but when they do, it just gives me a chance to learn. So I wouldn't say I'm frustrated by things going wrong. I'm interested. Let me move my scooter out of the way here because I have people walking on the sidewalk. Okay, so let me just show you what's happening here. Okay, so I'm just going to mention that last time this sprocket free spun because I tried to make the sprocket, a larger sprocket, one that wasn't meant to fit on this. I tried to make it fit with JB Weld, and the JB Weld just broke and it free spun. Now, this one's free spinning, and I'll show you what it's doing. I just now noticed it just now. So everything was going really well until, I'm going to show you what's happening, until this happened. See that? And what I'm seeing is there's a little, I need to start keeping more tools with me because this is something I probably could make. This is something I could make if I had like a nail or something. There's a Carter pin that goes in there. I think that's what it's called. And it came out, or it broke or something. So this is just free spinning now. Yeah, it looks like that might have been it right there. Trying to get my light to go in there. Let's see. So I can't ride the scooter at the moment unless I can find something to put in there in this hole. Anyway, it's just free spinning. I'll show you again. It's just free spinning. So I just need a little metal pin that goes in there. That's all. That's all it needs. Now, can I find a nail or a piece of metal? These are my. This maybe I can use one of these, but I kind of need more tools. Thanks. Someone said that's a cool bike, and I said thanks. Okay, let's. Well, I think I might stop the stream because I need to figure this out. I'm just thinking if there's anything on the scooter that I can use that would go in that. I should have brought more tools with me, and I didn't think of that. I do feel that it's something I can fix, though. For example, if I had... Actually, like these would work for my meter. The voltage was staying up very well. So this is still working. The alternators are still charging very well. So the alternators are doing a very good job of keeping the batteries charged, keeping these two and these two, which are series, and parallel, 24 volts, running this controller, which is powering the 500 watt 24 volt drive motor. And this motor is being powered by these 4 batteries in series, which is spinning, turning the alternators. The alternators are going into 3 full wave bridge rectifiers wired in series, which adds the voltage and keeps the amperage of 1 alternator. So these are like 20 amps each. So we're gonna have 3, add the voltage 3 times, and the amperage of 1. So all was going well until I lost the pin in here, or it broke or something. And now this, I need to find a way to put something in there. I'm thinking if I had some wire cutters, I could probably cut, like for example, this battery only has this going to it, right? I don't need all this right now. So I could connect this to the battery terminal and cut a small piece of this wire that has solder on it that's real hard. And if I had like pliers and a hammer, I could find the hole. Excuse me. I could find the hole. Let me just move my scooter out of the way. I could find the hole in here and then there it is. There's the hole. Yeah, this does not look like something that should be too difficult. You can see the hole there. See the hole? That's it. It's right there. That's all I have to do is put something in there and then I can ride the scooter again. Okay, I'm just thinking maybe I could find a nail or something. Let me see. Just thinking what I can do here. For those of you just joining us, the scooter, the pin that goes into to this sprocket here, it looks like it fell out. So it's just free spinning. So I need to put something in there that I can that will let me ride the scooter again, because right now the motor's spinning but this isn't turning, so I can't move the scooter. So alternators are charging still very well. Everything else is working well, except for I just need to find something I can put in here. Right now I am thinking of possibly using one of these, just sticking this in there and breaking it off and seeing if that'll work. I'm just looking at the scooter to see what else is on the scooter that I might be able to use. Okay, let's see. What else can I use on the scooter? See if I can use this. Something in here. Just an extra part on the scooter. Okay. And there's a screw here. I don't think that's the right size. So I'm starting to think that in my toolbox or tool bag that I want to start keeping with me when I ride the scooter, when I'm testing, I want to have a Dremel, some nails. See, if I had a nail right now, I could stick it in there. I do have these wire pieces with me. I don't know if one of these would fit in there. Okay, just looking for a way to make a part for this. Just seeing if this might fit in there. Okay. Maybe I can use... I'm still open to using this piece. This might work. It looks like it's a little small. Okay, well, either way, I think I'll stop the stream, and if I get this going, I will start the stream back up and continue work more on the test. But the scooter will ultimately be fixed soon, and we'll see you soon again. Thank you for joining the journey, and please do, again, like I mentioned before, please do share your ideas on an improved version of this concept here, which is alternator charging system for electric motorcycles. You can find this on a Google search, International Research Journal of Engineering and Technology, and it just basically shows how by putting alternators on an electric motorcycle or an electric vehicle, you can extend the range because it's been achieved already. And many people have done this, but this is one example. It's just showing that with the regenerative system is the alternators basically in this test, and it's showing with the alternator charging system it goes further than without it. So if you have ideas or links or anything that you can share with me that would help me improve upon that idea, please do share. Look forward to seeing you next time, and thank you for watching the video. Have a great day. Bye.